Hi everyone, Chris here, and you are on to U Science Lab. Today, we'll be looking at how to manipulate NECO physics practical on electricity. Okay, for those of you that have watched my previous video on this, you may be familiar with this setup. Now, this setup was designed based on the materials they asked to provide. Here you have a cell, you have the rheostat, you have the resistant bus, you have an ammeter and the bulb. Now it is suffice for you to know that this arrangement may not be exactly like this, but this is a series circuit. What do I mean by that? It means that each of these components can take different positions, okay? But this is a series connection. Irrespective of how it is connected, you are expected to read the values the same way they are, okay? Now let's take a look at the physical connection of this circuit before we go on to manipulate this value, okay? Okay, so I have my battery. The battery could be a 2-volt, a single 2-volt by lead accumulator, or two combined 1.5 volt, making 3 volts dry cells, okay? Then I have my rheostat. My rheostat is also known as the variable resistor. Then I have my resistant bus. Then I have my ammeter. I have my bulb. Then finally I have my switch or my switch or my key. Now this is how I'm going to connect this. The positive terminal of the battery is going to be connected to one terminal of the rheostat. Then the other terminal of the rheostat will be connected to the resistant bus, and the other terminal of the resistant bus connected to the positive terminal of the ammeter. This is because we have already connected the positive terminal of this battery to this side. So the positive terminals always connect with each other, while negative terminals connect with each other. So we are going to connect this to the positive terminal of the ammeter, then the negative terminal of the ammeter connected to the bulb, then the other bulb. The bulb does not have a terminal, so any of the side that you place it, either here or here, it's okay. So the remaining other side will now be connected to one end of the switch or key. Then from the key, we then connect back to the negative terminal of the battery. Okay, so this is the basic connection, how it's going to look like the physical connection with wires. Okay, now let us head to the point where I am going to show you how you are going to manipulate these values. Okay, now let's go and do that. Okay, so let's take a look at the setup again. This is the circuit diagram for what we want to do. Now, irrespective of what it's going to look like, it doesn't mean anything. It could be, the setup could be different from this, but whatever I want to do here today is going to be very important for you to achieve your result. Now, the first thing I have to do is to write the EMF of this cell. The EMF of this cell, I am assuming that I am combining a two 1.5 volt cell together. So the EMF is going to be 3.0 volt, okay? So the EMF is 3.0 volt. Then another parameter that you need is the internal resistance. The internal resistance of a 1.5 dry nickel cell usually varies from 0.5 to 1.5, okay? Now, but it may be greater than that if due to the age of the battery, the age and the usage of the battery, okay? So I'm assuming I'm having a new set of battery, and I'm going to peg the internal resistance at 3.0. Why is it 3.0? Because I have two cells, 1.5 volts combined together. So the internal resistance is going to be 1.5 plus 1.5. That's going to give me 3.0. So the internal resistance, R, small r, is going to be 3.0 also. Then another thing you need to note now is this: you're going to set a resistance for the bulb. So my resistance for my bulb R is equal to, so I choose a bulb of 0.3 watt ohms. Okay, so this is ohms. not volts. So this is ohms. So this is going to be ohms, okay? So that's this. Then again, we have I'm going to let the resistance of the resistant bus, let me just call that R1. So we're going to have the values for this. So we have the values for this as these values here: 1.0, 2.0, 3.0, 4.0, 5.0, 6.0. This may not be the exact value, okay? They may not be the exact value, but this can be a template to guide you to what you need to know, okay? Now the next thing we have to do, we are going to apply this formula. We know that current flowing through a circuit is given as I is equal to E divided by total resistance plus the internal resistance. Okay, here my total resistance, R total, R sub T, is going to be equal to the resistance of the bulb, the resistance of the bulb plus the resistance of the internal what? Resistance. So my R total is going to be R plus RI or R1, and whatever you want to call it. I just label this. Now take note that this I am doing, you are not required to do it inside your workbook. You are just required to do this somewhere else, okay? You just maybe on your answer booklet, and then you do it that with a pencil so that you can erase that, okay? So now this is what I'm going to do. Now the maximum current that is going to flow through this circuit, I'm going to call that either I0 or IM, whatever you want to call it. You may be asked to record that. What do I want to do? In this circuit, this is what they ask you to do. You may be asked to do this, to adjust the rheostat, okay? To adjust the rheostat, this rheostat here, so that you get a maximum current. And you're going to fix the maximum. Once you get the maximum current from the ammeter, you are going to fix that position, leave it permanently. Then you are now going to be altering the resistance of what? The resistance bus, okay? You see, I don't have a question for you, but I have already told you what you are to expect. It's not compulsory that must be the question, but you should expect something like this. So if I fix the resistance bus to read a maximum value of I0, you record it down, then you are going to vary all of this. Now, the essence of doing this is for you not to waste your time in carrying out this setup. Just get your readings manipulated. So my I0, since now when you are taking your I0, the resistance bus is closed. You are not taking out any, you are not unplugging any plug from the resistance bus. So it therefore means that the resistance from the resistance bus will not be recorded, will be 0, okay? So the only resistance, the total resistance that will be present is going to be the resistance of what? The bulb only, okay? And that is 3.0. So the maximum current is going to be E divided by my arrow total now is now what? 3 plus small arrow, which is what? 3. So my big arrow is, my E is 3 divided by 6. Okay, when I divide that by 6, my I0 is going to be equal to 0.50. So that's my maximum current. Now you see that they ask you to provide an ammeter that can read just 1 amp, okay? So you are not going to get a current that exceeds 1 amp, okay? Now the next thing I have to do now is to get the current when I unplug this: 1 ohm, 2.0 ohm, 3.0 ohm, 4.0 ohm, 5.0 ohm, 6.0 ohm, okay? So let me unplug all of that now. So when I unplug one, now my total resistance becomes what? 1 plus the resistance of the bulb, which is 3, that's 4. Okay, so my I1 is going to be equal to 3 divided by 1 plus 3, that's 4, plus the internal resistance. In fact, what you're going to do is this: let's just add the internal resistance plus the resistance of the bulb. We'll add the resistance of the bulb plus the internal. That will give us what? 3 plus 3. That's equal to what? 6. So what I've just done is that I'll be adding this resistance here, this, and this to 6. So the first one is going to be 6 plus 1, that's 7. So I'm going to divide that by 7. Okay, that's going to give me, when I divide that by 7, I'm going to get 0.43. 0.43 what? Amp. So it means that my first current here is 0.43 amp. Okay, then the next I'm going to add 2 to 6, that's 8. So I'm going to have 3 divided by 8. So I2 is going to be 3 divided by 8. That's going to be equal to approximately 0.38. So I have 0.38 here. Okay, then the next current is going to be 3 divided by, I'm going to add 6 to 0.3, that's 9. So 3 divided by 9, that's approximately equal to 0.33. So I have 0.33. Okay. Next, to get I4, I'm going to add 4 to 6. That's going to give me 10. So I'm going to have 3 divided by 10. That's 0.30. 0.3. That's going to give me 0.3. But I have to add 0 to make them, all of them, 2 decimal place. Then for I5, I'm going to add 5 to 6. That's going to give me 11. So I'm going to have 3 divided by 11. That is equal to 0.27 approximately. 0.27. Okay, then the next one is I'm going to add 6 to 6, that's 12. So I'm going to have 3 divided by 12, that's going to be equal to 0.25. 0.25. So this is my table. Now, whatever, you may be asked to evaluate arrow inverse. Okay, it's possible for them to ask you to evaluate arrow inverse. So this is going to be per ohm. So when you are asked to evaluate arrow inverse, you just divide arrow 1 by what? Arrow, whatever arrow is. Okay, so let me divide this through. So 1 divided by 1 is 1. I'm going to give this to 3 decimal, 1.000. Okay, 3 significant figure. 1 divided by 2 is 0.5. I'm going to give 0.500. So you are going to hold on while I work on this. While I work on the others, then I'll pause it and work on the others. So these are my evaluated value. Now I'm going to plot the graph now. So hold on while I plot the graph and see what the slope is going to give to us. Okay, now let us plot the graph of I on the vertical axis and arrow inverse on the horizontal axis. So that's the basic thing that I feel that we can plot on this graph. So now I'm going to mark out my vertical and horizontal axis. Okay, to mark that out, this is what I'm going to do. So let's our current, the lowest value is 0.25 and the highest is 0.43. So this is what I'm going to do. I'm going to write this current in standard form, as in the power of 10. So the first current there is going to be 43 times 10 raised to power minus 2. So I'm expressing the current in powers of 10. What have I done? Just come to this place, move this 1, 2. Okay, so that will be very easy for us to read. So that's 43 times 10 raised to power 3. So for 38, 0.3 is going to be 38 times 10 raised to power 38. Then for 33 is going to be 0.3 is going to be 33 times 10 raised to power minus 2. For 30, 0.3 is going to be 30 times 10 raised to power minus 2. 0.27 is going to be 27 times 10 raised to power minus 2. Then I have 25 times 10 raised to power minus 2. Now the next thing I have to do is to check for the values I'm going to put on the vertical, on the horizontal axis. This one's here. Now you can see that the highest value is 1 and the least value is 0. So I need to count this way and see if I can get from 0 to 1. I can fit all of this. I think it's going to be, now if I have 10 of this, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I fit it on this side, it's going to be enough for me. So I'm going to draw my y-axis here. I'm going to draw it here. That's how it's going to fit for me. So I'm going to draw it from this point. Okay. Now let me increase the size of this so that we can see that clearly. Okay. Then for this, the values are not too much. So if I'm going to move from 0 to, let's say, 50 or 45. So if I start from a 0, I'm going to have 10, 20, 30, 40, 50. See, the graph is so small. So it means that I can extend it to 2. So if I start from 0, I have 10, 20, 30, 40, 50. So that will be better for me. So I've come to this place. So this is going to be my 0 mark here. So this is going to be my 0 mark. So I have 0, I have 10, I have 20, I have 30, I have 40, I have 50. So this side, what am I putting here? I'm putting I. So the current, this is I times 10 raised to power minus 2 ampere. Please don't forget that, because here, you remember that you have written this number in powers of what? 10, okay? So now let me draw my horizontal axis through this point here. So I'm going to draw my horizontal axis through this point, okay? So if I draw my horizontal axis through that point, then I'm going to start this from 0.1. Oh, sorry. 0.1. So I'm going to have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1.0. So I'm going to write here, this is arrow inverse in per ohms. Okay, so now let's plot the point. It will be interesting for you to know, to make this thing easy for you. Now you see that we have two of these lines, 1, 2. Two of these lines, when you do this, 1, 2, that will be 1, another 2 is 2, another 2 is 3, another 2 is 4, another 2 is what? 5. So the midpoint is 5. So two of the lines will definitely be 1, and for this, one of the lines is going to be 0.1, okay? It's going to be 0.1, 0.1, 0.2, 0.3, 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, and 0.1. Okay, so let's plot the point here. We are plotting 43 against 1. Okay, so we're going to read 43 off here. So go to this point here. You come to, this is 1. Trace it up to 43. So this is 40. Remember two of the lines. So this is 41, 42, 43 here. So I'll go to that place and put a dot. Then I'll draw a circle. Okay? Now let's go to 38 for 0.5. So this is 0.5 here. So I'll go to 38. This is 30. This is 30 here. So this is 0.5. I'll go to 30. And we'll go to 38. Two of them. So I have, okay, this should be 35. Yes, halfway. 35. 36. 37. 38. You have to bear with me because the graph is very tiny here. 38. Okay, so put a dot here and draw a circle. Okay, so let's go to the next one. 33 for 33. That's 33 for 0.33. So this is 0.3 here. So I'll move 0.3 to 33. So this is 30, 31, 32, 30. So I have to count 3 places this way. 1, 2, 3. Okay? Because it's 0.33. So that's 30 here. Okay? Put a dot and circle it. So let's go to 30 for 0.30. That's 30 for 0.25. So I'll go to 30. This is 30. This is 30. Okay, this is 30. 0.25. So I have 1, 2, 3, 4, 5 as the midpoint here. Okay. So I'll put a dot and I'll draw a circle. So we'll go to the next one, 27 for 0.2. So this is 0.2 here. 0.2, I'll trace it to 27. This is 20, 25, 26, 27. Okay? So I'll put a dot here and draw a circle through it. And the last one is 25 for 0.167. So this is 25 here. This is 20. This is 25. I'll go to 0.167. That's almost 0.8. 0.1. So this is 0.1. 1, 2, 3, 4, 5, 6, 7, 8 here. Okay? So this is 8 here. Here, I'll put a dot and I'll draw a circle. So the next thing I have to do is to draw my line of best fit to fit into this line. Okay? So take your line. I'll draw my line of best fit. Draw it from this point. Let's see if it fits into this. Okay, I think it can fit into this, and this, so that this will be up and this will be down. So I'm going to draw this through this point. Okay. Okay, that's perfect. So let me readjust this. So it passed through this point. You may be asked to look for the intercept. So you can, let me reduce the width of that line so that you can see it clearly. Okay, so this is my line of best fit. The next thing you have to do is to take any point and draw straight line and draw dotted line on there. Let me take this point. I'll take this point and draw it down. Draw it down. Use a ruler to draw it. Ensure that the triangle, right angle triangle they are going to draw is going to be large enough and it must touch the curve. Okay? Okay. So let me read off this point. I'm going to read off this point from here. So this should be at this point here. Let me just approximate. That's 50. So my slope S is going to be equal to 50 minus, then I'm going to read this other point here, that's 20. Now remember that here there is times 10 raised to power minus 2, so you are going to include it, times 10 raised to power minus 2, and the unit is ampere, divided by, okay, so we'll trace this downward, that's 0.8, minus, so I'm going to trace, you can just trace it down this way so that you can read it off. Okay, then you trace this point that it touches this way, trace it downward also carefully. Okay, so I'm going to read for this is 1, this is 1, 2, 3, 4, so that will be 0.04. 0.04. So my slope S, the unit of this is ohm, per ohms. It's per ohm. Now remember, when you are divided by per ohm, the ohm goes up and becomes an honorary word, ohm. So my slope S is going to be equal to 50 minus 20, that's 30, times 10 raised to power minus 2, divided by 0.8 minus 0.04. That's equal to 0.76 per ohm. This is ampere, okay? So when I divide this out, I'll just divide this as that 30 exponential minus 2 divided by 0.76 is equal to 0.394. So my slope is equal to 0.395 approximately ampere watt ohms. That's my slope. Okay, now there is something I have not included here, the title of the graph. So the title of the graph is the graph of what are we plotting against what? I in ampere against arrow inverse in per ohms. Then you are going to put the scale here. So it's very easy. On the I axis, my scale is 4 cm. This is 4. When you count this is 2 cm. When you count this is from here to here is 2 cm, and from here to here is on that's 4 cm. So the numerical unit that is here is 10 times 10 raised to the power what? Minus 2. So 10 times 10 raised to the power minus 2 ampere. 10 times 10 raised to the power minus 2 ampere is simply the same thing as 0.1 ampere. Okay. Then on the arrow inverse axis, I'm using 2 cm. From here to here is 2 cm. That's 2 cm to 0.1 watt ohm. So on the arrow inverse axis, 2 cm to 0.1 per ohm. Okay, so that's my scale. Now if you are asked to get the intercept, just come to this place and read off this point here. So this should be 1.5, this is 1.5, 1.52, 1.54, 1.56, 1.58. So it's 1.58. So my intercept I is equal to 1.58 ampere. So that's my intercept, 1.5 watt ampere. So that will be all for this, and I'm sure that this will be helpful to you in carrying out what this physics practical. All right, let me see you in the comment section, and also like and share this video. Please do ensure to subscribe